You are traveling from Hyderabad to Tirupati. You don't randomly jump from one road to another. You travel through a sequence of roads. Some roads have no diversions. Some roads have multiple exits. Some roads merge from different directions. Similarly, when a compiler analyzes a program, it divides the program into small sections and studies how control moves between them. These sections are called basic blocks. The movement between them is represented using flow graphs. Today we will understand both in a very simple way. Welcome back to Mana CS Classroom. In the previous videos we discussed code generation concepts. Today we will learn one of the most important concepts used in optimization and code generation, basic blocks and flow graphs. Suppose a program contains hundreds of statements. Analyzing the whole program at once is difficult, right? So that is why we need basic blocks. So the compiler divides the program into smaller meaningful units. These units help the compiler perform optimization more efficiently. Imagine a room full of books scattered everywhere. Finding a book becomes very difficult. Now arrange books shelf by shelf. Suddenly everything becomes easy to manage. Similarly, a compiler organizes program statements into basic blocks. So what is a basic block? Basic block means a straight line sequence of statements. Execution always enters at the entry of or at the beginning of this block and continues statement by statement and leaves only with the last statement. No jumps occur inside the block. Only the first statement can receive the control and only the last statement can transfer the control. Okay, that is what a basic block is. So example, let us look at an example. See, here we have three instructions. A is equal to B plus C. And the execution continues with D is equal to A minus E, and then continues with the third statement, F is equal to D star 2. There are no jumps and there is no deviation. So all these statements, three statements together, we can call as a basic block. Okay. Then where does the next basic block or a new basic block start? So how to find another basic block? The rule is very important. A new basic block starts when the statement is the first statement of the program, or it is a target statement of a jump statement, or the statement comes immediately after a jump instruction. Okay. So the first statement of a basic block is called as leader. So first we need to find out, we must learn how to find these leaders. So there are three rules to find these leaders. So every first statement is a leader and jump target is a leader and statement after jump is a leader. So the finding leaders is the first step in constructing basic blocks. So we shall see one example program. See, now let us identify the leaders in this example as per the rules that we have seen in the earlier slide, in the previous slide. The very first statement is one leader, right? So this is one leader, okay? And the target of, so here I'll just number the lines 1, 2, 3, 4. So go to 6 is the target of an instruction. That means 6th instruction is also a leader. And the instruction which is immediately follows a jump is, see, here is a jump, go to 6 and go to 7, here is a jump. Okay, 7 is also a target, right? Okay, so 7 is also a leader and the instruction which is immediately follows a jump statement means here we have a jump statement, so the next statement is a leader. According to the rules that we learned, So what are the leader statements here? The very first statement is a leader, and as there is a target line, 6 is a leader, and immediate instruction after a jump, that is a fourth line, is a leader, and there is a target number 7, that is why seventh line, seventh instruction is a leader. So these are the leaders that we found. So using these leaders, how to divide this entire program into basic blocks? You start with the first leader and collect all the instructions before reaching the next leader. Okay. So according to our previous investigation, we found the leaders 1, 4, 6, 7. So start with one leader, collect all the lines before reaching the next leader. That means 1, 2, 3, do not include the next leader. 4, we should not include 4. So 1, 2, 3 is one basic block. Okay. And next 4, starting with the next leader, 4, and do not include the next leader. So 4, 5 is another basic block. 4, 5 is another basic block. 6 alone is another basic block, and 7 is another basic block. Okay. So that is how we must learn how to find the leaders. So basic block 1 has statements 1, 2, 3. Basic block 2 has statements 4, 5. And basic block 3 has only statement 6 because 7 is again another leader. So we should not include another leader. So 7 is another basic block. Okay, once the leaders are identified, the statements are to be grouped until the next leader appears. So we obtained 4 basic blocks. Okay. Next, what is a flow graph? So after creating basic blocks, the compiler wants to know how control moves among them. For this purpose, it constructs a flow graph. Each basic block becomes a node and control transfers from one basic block to another basic block. This control transfer becomes an edge. Okay. So for previous example, flow graph. So from B1, if you observe carefully, from B1 condition can be true or false. If true, execution goes to B3, or if it is false, if it is no, then execution go to B2. Eventually both paths reach B4. So this graphical representation is called a flow graph. So here I just mentioned B1, B2, B3, B4. You may mention a block, a rectangular box which has instructions in it as basic blocks. Okay. So what are the advantages of basic blocks? So basic blocks help the compiler understand the structure of the program. They are widely used in optimization techniques. Loops, unreachable code, and redundant computations can be identified easily. Okay. So let us summarize. Let us quickly revise. A basic block is a straight line sequence of statements. A flow graph shows how execution moves among basic blocks. So now we know how a compiler divides program into basic blocks and represents them using flow graphs. In the next video, we will see how a compiler actually generates the target code from these structures. See you in the next class. If this video helped you, like, share and subscribe to Mana CS Classroom. Thank you.